For me, it's a business I've been doing for the last 38 years. I belong to a service background with my father being a government lawyer. As an engineer by qualification and years of experience, today I'm proud to steer one of the fastest growing high-tech manufacturing companies of the country. I was fortunate to have hands-on experience in every department, design to production, to sales and marketing, having sufficient exposure which has been used constructively towards the growth of the company. Supported by a pool of young talented Indians, we have always focused on solution-oriented approach and application engineering, creating new markets for our product. This has given us an edge over competition. Current economic indicators project a very encouraging image of India as a robust, fast-growing economy with least risks. The world is bullish on India, and so am I, on the growth of Everest. We have a strong succession plan with highly competent second generation to carry on the mantle of Everest.
In 1998, Everest Blowers Group went on to get its first ISO certification and also crossed international borders by exporting the products overseas. Over the years, Everest Blowers Group has made sure that it has abided by all industry norms through various certifications. The Everest Blowers Group has been associated with many different industrial giants from different verticals, bagging prestigious orders from them. An innovative thinking and approach has made the company excel in many first-time achievements. Everest installed their first CNC machine in mid-2000s and since then has increased number of equipments to cater to the growing demand of the market. Everest started manufacturing their range of tri-low blowers as a more efficient alternative for reduction in noise and vibrations. The group has received accolades and admirations in the recent years, touching the sky. The vacuum systems facility also started a dedicated unit to cater to the needs of complete skid-mounted systems requirements of our customers. The vacuum division is currently manufacturing around 350 to 400 complete skid-mounted vacuum systems annually, with a very wide industrial base spread across various applications. The Everest Blowers Group is proud of its journey in scaling new heights and is in the pursuit of excellence. We are following latest industrial practices of Kaizen, 5S, and other lean manufacturing techniques. To always remain connected with our stakeholders, we are available on all the leading digital platforms and have an online complaint portal, technical manuals, and a vacuum calculator.
It's been a little over 8 years since I've joined our family business, and we've experienced good growth with some diversification. I really enjoy what I do, as every day is a new learning of something interesting helping us serve our customers better. So at Everest, we believe in very strong fundamentals of quality and innovation. We are the first and only company in India to have manufactured dry screw vacuum pumps, mechanical vapor recompressors, amongst many other products. With presence in the Indian market for over 3 decades and more than 150,000 equipments successfully installed, running in 38 countries worldwide, we are a trusted brand. Our vision is to further build and sustain a positive relationship with our customers, to have an innovative and motivated work environment, and to ensure a bright future for all our stakeholders.
The Everest Blowers Group, standing tall like Mount Everest, reaching for the sky, now and forever.
Hello everyone, I'm Chetna Sharma, representing Everest Vacuum, the brand of Everest Blower System Private Limited. Welcoming you once again on our fifth webinar, which is being organized on dry vacuum pumps for biodiesel and bioethanol production. And the content which we will cover in this webinar are: first, we will explain you about the Everest. What is Everest? Like how we achieved our path and how we followed our path on where we right now we are standing. And after that, we will move to our main content of the agenda of this webinar, which is biofuels. Then we will explain you about the biodiesel and bioethanol manufacturing process. Moving forward, we will explain you the most important thing, which is the role. What is the role of vacuum in biodiesel production? Then we will explain you about the benefits, features, and advantages of our dry vacuum systems. All of these information we will explain you with one of our case study and the cost benefit analysis. Then we will explain you about the contaminations and how we can control it. Then we will moving forward. We will explain you about the rule of 2030 as we explained you in our previous webinar also. Last but not the least, Q&A session in which I would like to request everyone, please put your questions in the Q&A box and we will try to give everyone's questions answer as per the time permits us. So moving forward, I would like to request Mr. Rakesh Ahuja, who is the GM Sales of Everest Vacuum. So Mr. Rakesh.
Thank you, Chetna. Good afternoon, everyone. Let me once again offer you a warm welcome for having taken out your time to join us in this session of a series of webinars that we are conducting for our. Let me give you an introduction to our organization. Everest Vacuum is a 13-year young company of Everest Group, which was started with the objective of providing turnkey vacuum solutions. Through our parent Everest Group, we were already manufacturing and supplying mechanical vacuum boosters to our customers. During this course, we realized that there were hardly any structured players in this segment, providing complete engineered skid-mounted vacuum solutions, which were rightly sized to the customer process requirements. The customers were typically purchasing vacuum pumps from one source, boosters from another, and obviously they were integrating it themselves. And thereafter facing issues, on and so forth. Of course, that was troublesome, both in terms of operations of the equipment as well as operational efficiency. That's when the management of Everest decided to work in a structured way and offer a complete comprehensive solution on turnkey basis to our customers. We studied our customers' requirements, and with over decades of experience, we successfully started engineering the most effective and optimized vacuum solution so that our customers can focus on their strengths and we are able to focus on what we provide in terms of solution. At Everest, we have a mission statement, which is called Mission 555. And our mission is to provide innovative engineering solutions in the entire range of vacuum and manufacturing, with a clear thrust on training and development of our employees, continuously expanding our operations, markets, and possibilities of collaboration to service our customers better. Our mission, therefore, 50 CR to 500 CR in 5 years. And that's our mission, 555. Chetna? Let me also introduce to you. We offer dry screw vacuum pumps. We offer mechanical vacuum boosters, industrial engineered vacuum systems, liquid ring based, which are also called as semi-dry vacuum systems, oil ring based, similarly called as semi-dry vacuum systems, rotary vane vacuum pumps and systems, and zero liquid discharge or temperature thermal evaporation. These are some of the pictures of the products that we manufacture, as well as the complete solutions that we provide to our customers. What's our promise? Our promise is clean, reliable, and sustainable vacuum, improved product yield, deeper and consistent vacuum, cost and space saving by right sizing, resulting in reduced operational cost. Chetna?
Thank you so much, Mr. Rakesh, for giving us such a good brief about your product and about your organization. Now, I would like to request Mr. Priyanshu, who will lead from here, and he will explain you about the biodiesel production process and what is the role of vacuum in biofuels. So, Mr. Priyanshu, please.
Thank you, Chetna, and good afternoon to everyone. So what are biofuels? Biofuels are any fuels which are derived from natural sources, oblique biomass. And these are renewable sources of energy. Why do we say renewable sources of energy? Because these can replenish themselves over the course of time. And why do we need to talk about biofuels? As we know, the energy requirements are continuously rising, but the supply of conventional fossil fuels is limited. Therefore, we need to look after some alternative sources, and biofuels as alternative fuel sources are giving us a very promising results. Biofuels are well-engineered fuels, which are also gaining popularity due to the rising cost of fossil fuels. The most common biofuels are bioethanol and biodiesel. On one way, while biodiesel is manufactured by transesterification, bioethanol is manufactured by fermentation. The largest possible source of suitable oil comes from crops like soybean, rapeseed oil, corn, and sunflower. Here are some of the pictures depicting us the sources of biomass. As we can see, wheat, jatropha, palm oil, and other crops are displayed here. The suitable feedstock which we can use to manufacture biofuels can be classified into 4 generations. In first generation, we have the food biomass, such as the starch and sugar-rich crops. Second generation comprises of non-edible feedstock, which is generally agriculture and forestry waste. The third generation is the integration of marine algae, whereas the fourth generation are genetically engineered crops. As we can see, the feedstock, which may be animal fat, biomass, or any other oil or crop, can be processed either via fermentation or transesterification to give us ethanol and biodiesel. Let's start with biodiesel production. Biodiesel is produced by the process of transesterification. As we can see from the reaction here, 3 moles of alcohol react with 1 mole of oil in the presence of a catalyst to give us biodiesel and glycerol as the end products. The catalyst has to be a strong acid or a strong base. Generally in the industry, sodium methanolate is used as the catalyst. Here is a picture of raw biodiesel and glycerine, which is obtained by this transesterification reaction. This is obtained through this separator. Once we have separated the biodiesel and glycerine, this is how the biodiesel is looking after the washing process, and this is the pure palm biodiesel oil. This glycerol, when purified and cleaned, can be used in the food, oleochemical, and cosmetic industry. Here we are depicting that the vacuum systems are connected to the separator where we need to separate biodiesel and glycerol. In this process of transesterification, we can see that for any plant oil, methanol is the most commonly used alcohol in the industry. And since we are transestering methanol with the oil, the product which we receive is methyl ester. Vacuum pumps and compressors, which we mentioned, are used in the separation of biodiesel and glycerine at this stage and extracting wet and saturated gases during this stage. In methanol recovery, glycerin purification, and many other applications. If we take a typical example, we have 1000 kg of oil, which is put into with methanol, sodium methanolate. What we receive out of the reaction is 1000 kg of fatty acid methyl ester, some glycerine, and free fatty acids with roughly 1 to 2% of moisture content. This is generally a batch operation where the temperature ranges from 70 degrees to 250 degrees and the working vacuum is in the range of 100 torr to 0.5 torr. Coming over to bioethanol production, we can see if we have sugar-rich crops, such as sugarcane, we can directly put it into fermentation. Or if we have corn crop and other cellulosic crops, we need to put in through hydrolysis before we can process for fermentation. Bioethanol is obtained from the fermentation of vegetable materials. Some crops could be sugarcane, potatoes, wood, and grass. In fermentation process, these biological materials are transformed into other substances by adding enzymes. Once we are through to this fermentation process, our raw material, which is sugar, this breaks into ethanol by liberating carbon dioxide. Now at this distillation, before this distillation, the ethanol which we receive is 7 to 10% pure. We can distill the ethanol to get up to 70% purity. By further distillation and reflux techniques, we can improve the purity to 95%. And at that stage, when we adopt alcohol dewatering technique, we receive bioethanol, which is 99.5% pure and also known as fuel grade ethanol. Vacuum pumps are used during the distillation and rectification and reduce the energy consumption of the process, guaranteeing an economical production of the final product. This is a cycle These were earlier done either by using conventional systems or using wet vacuum systems, none of which can offer the same efficiency as using dry vacuum systems. Therefore, dry vacuum packages from Everest, which offer efficiently high vacuum, are rugged to process variations, also capable of handling process vapor and liquid carryover, making them the ideal choice because of their reliability in producing consistent vacuum. This is a typical process setup for biodiesel production. If we can see, we have connected a vacuum system in the separator stage where we are separating biodiesel and glycerine, and further the vacuum system is connected during the stage of removal of free fatty acids and moisture. This is a typical vacuum system supplied by Everest. Screw vacuum pumps, which are a flagship product, and we, being the first and only Indian company to having manufactured these in-house, these screw pumps operate using two counter-rotating screws. These rotors rotate in opposite directions and trap the gases in between the voids which are formed. These voids keep on decreasing, which not only compresses the gas, but also moves it towards the exit. Since the screw pumps have numerous facets, there are very micro spaces between the rotating screws, but still there is no requirement for any lubrication, and therefore we call it as dry screw vacuum pumps. They have a high tolerance against particles and low ultimate pressures, highly efficient for internal compression, and very low maintenance and operational cost. Some features and advantages are there's no steam requirement, which makes a system dry and also helps in cutting down the effluent generation and effluent treatment cost. The vacuum achieved is consistent and reliable. Our systems are compact, skid-mounted plug-and-play units. We ensure very high pumping speeds, robust design, low maintenance cost, high volumetric efficiency, and 100% dry pumping. We'll start with a case study where we have replaced steam ejectors with our mechanical vacuum system. The case in consideration is the replacement of a 4-stage steam jet ejector where a watering pump was used as a backup. What we have supplied is a 100% dry pumping SuperVac 10,000 where we have 3 stages of mechanical vacuum booster and a dry screw vacuum pump at the back end. There were these problems of excessive effluent generation, high cost of treatment, mixing of solvent, and vacuum fluctuation. Employing a dry screw vacuum system, we have given zero effluent generation, there's no cost of water treatment, and there's no utility contamination. We have also given consistent and reliable vacuum, and it has led to consistent product quality with higher yield. There was an interesting discovery during this case. When we installed a dry screw vacuum system, we found there was some choking in the screw pumps by the product carryovers. On investigation, it was identified as the free fatty acid which we were removing. This fatty acid was getting mixed and choking the pump. This is when Everest Technical Services came into the picture, and we addressed this problem by installation of safety accessories. Today, these systems are running at site trouble-free for more than a year. What did we do here? We installed an interstage condenser along with a proprietary vacuum trap so that we could arrest most of the incoming vapors, and 95% of those were condensed. We'll talk about the cost benefit analysis of this project, where our client is Matrix Fine Sciences Private Limited. Some process details are the products, those are alpha tocopherol and biodiesel. The process is distillation under vacuum, where we have supplied 10,400 meter cube per hour dry screw vacuum system, vacuum boosters with a dry screw vacuum pump, replacing their 4-stage steam jet ejector. As we can see in the cost comparison, their consumption of steam was 36 lakhs for the entire year, whereas the power consumption in our dry vacuum systems is only 14,28,000. The utility cost was 8,76,000, which came down to just 1 lakh rupees. The usage of an interstage condenser, which led to some solvent recovery, is saving almost 3 lakh rupees per annum. The maintenance cost slightly increased, but on the overall picture, when we see, there's a direct cost saving of 29 lakhs over a period of 1 year. Apart from this, the 18 hours batch came down to 16 hours per batch. And then the product quality also improved. This is a typical PNID of our vacuum system. What we are supplying here, our vacuum system is connected from the client system. There are 3 stages of mechanical vacuum boosters, our intermediate condenser, a proprietary vacuum trap, followed by a dry screw vacuum system. Along with this, we provide an electrical control panel which houses the VFDs for all the machines and a PLC to control the entire system. We have a vacuum transmitter installed with a vacuum controller so that we can set points we want to operate vacuum at. There's a safety features for solvent flushing to flush out all the condensable gases at the end of the process cycle. The continuously purging of nitrogen or instrument air. And this is the interstage condenser where we can recover most of the incoming vapors. A pictorial view, if we say, here's a dry screw vacuum pump with 2 boosters and an intermediate condenser. Based on our experience and understanding of the biodiesel production, we have standardized following vacuum systems. For batch sizes and continuous feeds, we have our models defined for pumping capacities. These start from 2000 meter cube per hour and go up to 18,000 meter cube per hour. These are 5 of our models which are standard but can be customized to suit your applications. We have a rule of 20-30 at Everest, where we believe by right focus and approach, in most cases, we can reduce the operating cost by 20% and target to increase productivity by more than 30%, benchmarking the existing conditions if we replace and select correct vacuum systems. Now we would like to talk about how to control the contaminants and improve on the pump performance. Now, process vapors and the condensation inside the pumps can create a great nuisance value. We have two options where we can avoid these instances. The first is of gas blasting or dilution techniques, where we can purge instrument air or nitrogen in the system. Instrument air can be used in any normal process, but if the gases which we are transferring are flammable, nitrogen needs to be used. Another popular approach is hot pumping, where we can run the pump hot. We use a thermostatic control valve to regulate the temperature of the pump jacket. We maintain the temperature at certain level so that the vapors do not condense inside the pump. Next problem might be through dust and particulates, which can be a byproduct of wide range of processes. To prevent particulate matter from entering into the vacuum system, Everest provides inlet filters suitably designed as per your process so that there's no contamination inside the pump. There might be some dust from corrosion while pumping aggressive gases. So it is highly recommended to select a suitable MOC whenever we are trying to design a vacuum system. At Everest, we have 7 golden rules for vacuum pump maintenance. First and foremost, the reading of operation and maintenance manual and following the preventive checkups as per SOPs. Rule 2 is following the warm-up cycle. Rule 3 is never to block the outlet of the pump. The discharge line should always be free from any blockages. Rule 4 is to install an inlet cold trap so that most of the corrosive vapors and contaminants can be trapped outside of the pump. Rule 5 is to use gas blast, which we discussed while we are working with condensable vapors. Rule 6 is to protect the pump from particulates with an inlet filter. Rule 7 is to properly run the pump with shutdown cycle and follow solvent flushing and purging. Simply stated, if we take care of our vacuum pumps, they'll take care of our process. As we mentioned, this is our 5th webinar. We have previously conducted 4 webinars where initially we talked about the basics of vacuum and the role of vacuum in industry. Then we talked about the selection of right vacuum pumps for chemical and process industries. We had a webinar on operation and maintenance of dry screw vacuum pumps. And most recently, we organized a webinar on the operation and maintenance of mechanical vacuum boosters. In line to our mission of providing innovative engineering solutions to our customers, the Technical Services Group at Everest Vacuum have initiated a program wherein we let you invite us to audit your process and give our expert opinion on what could have been the most efficient way to conduct that process. You can log on to the link below and register so that we can review your processes. Thank you. So I think now we can take on to the Q&A session. Over to you, Chetna.
Thank you so much, Mr. Priyanshu. for giving such a good brief about biodiesel and bioethanol process. Now, I would like to request everyone, please put your question in a Q&A box. If you have any kind of queries or you want to consult anything and you want to discuss any process, if you're facing any kind of issues even, please put your questions on the Q&A box.
So we have a question from Mr. Sarthak Soni. His question is, distillation of biodiesel has not been mentioned anywhere. Can you elaborate more on this? Priyanshu,
Sir,
would you like to take this question?
Sir, we already discussed that we have vacuum systems connected in line for the distillation process. I'll just go back to the slide.
I'll add to this. You see, at Everest, our objective is to provide and design a robust vacuum system. There can be multiple applications for which a system can be used. But the end objective of any vacuum system for that matter is to remove non-condensables. All condensables typically should be removed by a efficiently designed condenser. Now, whether it be separation or be it distillation or be it recovery, all are done under vacuum. The main reason for doing it under vacuum is to get more energy efficiency and to prevent hydrocarbon cracking. For this objective, vacuum system works out to be a very efficient method. And distillation under vacuum becomes distillation typically under vacuum, which may in other terms be called as separation, is the preferred way to go about it. Would you like to add something to this, Priyanshu?
No, sir.
Then we have another question from Mr. K.S. Rao, who says that he's an expert in biodiesel production. He says that mechanical systems might be prone to high maintenance oblique breakdowns. However, steam jet ejectors have no moving parts and can consistently provide one torr vacuum. What is your response to this? Please elaborate. I think I'll take lead on this on answering this question for him. So good afternoon, Mr. Rao. I am Dhruv Malhotra. I am with the TSG group at Everest. Our job is to ensure that we overcome such challenges working with in very close association with experts like yourself. I'll give you examples why steam jet ejectors are becoming a thing or are becoming points of concern. You see, earlier when steam generation was easy, contamination of water was not a problem, oblique availability of water was free, steam jet ejectors were the preferred choice. But with the fast changing scenario and pollution control boards becoming stricter and stricter, cost of generation of steam is becoming a heavy cost because mostly it has to be done through diesel fired boilers now or coal fired boilers, clean fuels, lot of auxiliaries, lot of compliances. B, the water that gets mixed with biodiesel, treatment of that water becomes a huge cost. Now we have closely been working with many companies. Like I told you, our objective at Everest is to only allow non-condensable vapor, that is the leakage of the system, to come or pass through the vacuum pumps. Even though these vacuum pumps are not very sensitive, they can allow certain amount of process oblique product carryover to pass through them. But at the same time, condensables should always be condensed in efficient condensers. We at Everest, like Priyanshu showed. Priyanshu, can you take us to the page where you showed an interesting discovery? Initially, when we supplied the system to this company, which is manufacturing biodiesel, we faced issues of frequent pump choking. We were able to identify exactly what was the reason. And after identification, we were able to eliminate the choking process, the reason only because of which it was choking, by installing proprietary traps in line before the vacuum pumps. Boosters per se have, the mechanical boosters per se have no effect of process material coming into them, unless and until it is solid process material, which in most cases does not happen because the operating vacuum is 1 torr, and at that operating vacuum there is no medium to carry away solid particles. It is only air that is being, it is only process vapors that are being carried on. So by using traps, by using efficiently designed filters and condensers, we are quite sure and confident that we are able to eliminate any process carryover that will lead to failure in pump. Now, this being said, if you study or read, the bigger the size of the system, the faster the payback, and you are able to, the cost that you can recover by efficient dry pumping is a much bigger advantage than the maintenance downtimes that you might face by use of mechanical vacuum boosters. Biodiesel is a new upcoming line in India, but we have been using such systems very heavily in other processes such as edible oils, deodorization of edible oils. Processes are all similar. It is just that the end product in various cases is changing. I hope I have been able to answer your requirement, sir. If not, then at the end of this session, we'll be sharing an email ID. You can just put in a mail, and definitely we'll have a 1:1 session with you. Thank you. Next, Priyanshu, is can you explain how effluent will be reduced by using this RVP? What is the meaning of RVP? I think RVP, by RVP he means rotary vane pump. Okay, Mr. Rohit, this is not a rotary vane pump. This is a dry screw vacuum pump. So in dry screw vacuum pump, because there is no product, no sealing fluid, so there is no contamination within the pump. In fact, at the discharge of the pump, we tell our customers to install a post condenser. Whatever vapor is passing through the pump is non-contaminated. It does not come into contact with any sealing fluid. It can be condensed at the discharge at atmospheric temperature and pressure and reused oblique recovered. Next is Mr. Dipen Shah. Can this dry vacuum system be used in FFA stripping and deodorization? If yes, can we see this in working condition installed at site? Definitely, Mr. Shah, we noted down. As I told you, deodorization, we are already using these systems for FFA removal only, where there is steam being inputted from the bottom to act as a carrier to carry away the FFA. We will definitely get in touch with you on this and share more details and give you better inputs. Okay, next question is by Mr. Rao. Methanol and biodiesel are corrosive to rubber and O-rings. And how do you manage the lip seals and O-ring failures? Where have you used machine boosters at biopharma labs? Good and cost-effective machines and alternate to costly mechanical boosters which are being imported. Thank you, Everest, in serving the industry. Okay. Thank you, sir. Thank you so much. You see, in this, I will answer biodiesel is corrosive to rubber and O-rings, yes. But in our case, we have some special O-rings which are Calres O-rings, which have very good life. These are the O-rings and the seals, lip seals that are used are specially designed PTFE lip seals, which again have nothing to do with rubber. These are high-speed PTFE lip seals, very similar to the ones that are used in aviation industry. This being said, in boosters, we have gone even a step further. All the boosters that are there come with labyrinth design. That is, practically there is no physical contact part, even in sealing within the booster. So you have no lip seal, no O-ring, which is coming into direct contact because it is biodiesel, a form of carbon, and we are using special grade oils or lubricating oils. It does not make a difference if there is traces of vapor that go into the vacuum pumps. We are already, a lot of our customers are already using these type of designs in such application. A similar application where our systems are very popular is used oil re-refining. At high temperature, these boosters give excellent life, with mean time between failures being recorded as high as 5 to 7 years. There is no problem that the customer face. Then we have a question from Mr. Rajvinder Bhamra. Please elaborate the use of dry screw vacuum pump in deodorization. Can we see a running unit near Delhi? Definitely, sir. We'll take down a note of your requirement and we'll have somebody from our team contact you on this specific requirement and he'll answer or look into your needs. Thank you. Then there is Mr. Pant. How is effluent discharge to ETB reduced by using these vacuum pumps? Okay, Priyanshu, can we go to the CBA sheet? You see, the biggest unique selling point, USP for our system is that there is no requirement for steam/water. Water is being used in our pumping jacket of the pump, but it does not come into contact with process vapor. So it is like to cool down that's the only requirement which is being used, where the requirement of water is there. Since there is no water or steam that comes into direct contact with process vapor, it does not contaminate the process vapor at all. Because there is no contamination of process vapor, whereas in case of a steam jet ejector system, this contamination is very high. Like in this particular case, if we are using a 4-stage steam jet ejector system, we are consuming 700, 800 kgs of water per hour. Now, all that water that is coming out is getting mixed with process solvents such as biodiesel, ethanol, or other various solvents. Now, to treat this water in itself becomes a cost. Whereas so that is why these systems are called as wet systems. Whereas if you see about a dry system will have no requirement of water or steam. It will be a it will be a system which will be working purely on basis of clearances within the dry mechanical vacuum pumps, whether be it a booster or a dry screw vacuum pump. So all the effluent or the process carryover vapor that is coming is getting condensed and controlled in the either the interstage condensers or the primary condenser or the tertiary condenser, the post condenser at the discharge of the vacuum pump. So there is no generation of solvent, effluent, which goes into ETP, thus reducing the load of the ETP drastically. Nishant, I believe there is one question from Mr. B.N. Reddy.
Mr. B.N. Reddy. He has a
Biodiesel.
question that biodiesel is solidifying in cold weather. Any solution for this from our end?
If it is solidifying in your kettle or in your process, I don't have a solution because that is beyond our reach. But in our vacuum system, we don't let it condense. So what we do is something which is called as hot pumping. Hot pumping, how does hot pumping work, or what is the concept of hot pumping is once the vapor reaches our vacuum system, our objective is not to allow vapor to condense within our vacuum system. If it condenses in the condenser, well and good, no problem. But within the pumps, it cannot or should not condense. If it condenses, it will lead to problems. So that's why we introduced the concept of hot pumping. Here, what we typically do is when these pumps are running, they are generating some heat of compression. Because of that heat of compression, they are getting hot. We circulate water in a jacket around the pump, very similar to what happens in a car engine. You have a radiator and you have hot water being circulated to cool down the cylinders. Similar thing happens in the pumps also. Now that same principle that works in the cars, that in winters, we regulate the temperature of the water in the pump by something called as a thermostatic control valve. The objective of that valve is to maintain the flow rate of the water to such a condition that the pump remains in hot state and does not cool down below a particular temperature. Now, typically, hot pumping, when we say hot pumping, typically it starts at say 75 to 80 degrees. At 75, 80 degrees, we ensure that there is no vapor that can condense within the pump. All vapor in vapor form itself will pass through the pump, come to the discharge and get condensed in the post condenser at the discharge, or if there is no post condenser installed, then it will be discharged into the atmosphere. I have got another question from Mr. Rao. Is vacuum sealed in system after power failure? Yes, of course, there are check valves that are in place. As soon as the power goes off, those check valves, these are mechanical check valves, they isolate the system and isolate and close the system. Priyanshu, do we have any more questions?
So we have one question from Mr. Veeragandham Subbarao, which I would like to answer to him.
Yes,
His
please.
question is, we use wood chips as fuel in our boiler to generate steam. If I want to replace the existing steam vacuum system with your dry system, what would be the operating cost? So, Mr. Rao, as you are aware that steam generation cost falls in between 90 paisa to 1 rupee in case of wood fired boilers. So even if you have a consumption of say 1000 kg per hour to maintain a vacuum of zero point 0.1 torr or 1 torr nearly, then the cost of operation will go to 1000 rupees per hour. But as Pranshu has depicted you a system of say 10,000 meter cube per hour, we have connected power as 40 or 50 kilowatts based on the customization. So accordingly, the power consumption, if you check 40 kilowatts, sorry. So if you check the unit cost at your end, say 8 or 10 rupees per kilowatt hour, so the cost of operation goes around say 320 rupees per hour. So you save 70% of your current operating cost, and you can save out on a huge amount of money annually if you operate 24 by 365. Um, so we have one more question from Mr. Rajvindra Bamra Saab. What are the temperatures in the vacuum pumps? Can you please elaborate on this?
Okay, so vacuum pumps can work under very vast spectrum of temperature. You can have vacuum pumps operating at say 4 to 5, 7, 10 degrees also. We do that in freeze drying applications where triple point of water is at 4 degrees. We need to operate below 4 degrees. And the highest discharge gas temperature that we can allow vacuum pump to pass through is 150 degrees in case of dry screw vacuum pumps. So the spectrum in which we are working is anywhere between 0 degrees to about 150 degrees discharge gas temperature.
I think we are done with all the questions. Gentlemen, if you have any, sorry, ladies and gentlemen, if you have any questions, you may please put up on the Q&A session, this sheet. Mr. Rao has one more question, sir. We can remove the FFA of the vegetable or animal fat by molecular distillation with the usage of dry screw pumps. Please share if you have any case study data like feed FFA and product FFA.
Before that, I will just reiterate tiny URL, tinyurl.com/Everest vacuum dash TSG. A Google form will open up. You can just open up that Google form and post in your queries. We'll directly receive them and we'll take it up with you 1:1. Hanji Nishan, sorry, you were saying something.
No, Mr. Rao was asking for a case study. Mr. Rao, we'll come back to you separately on the subject. We'll be in touch for clarifying more doubts of yours.
Priyanshu, back to you.
So thank you everyone, Mr. Pranshu, Mr. Dhruv and Mr. Nishant for giving a good whole information to the respective questions. So I would like to request everyone, if still you have any other questions, you can go to this site and put your questions and we will directly come to you and directly reach to you. So thank you everyone.
Thank you,
Thank you, everyone.
Priyanshu, for the wonderful webinar. Thank you, everyone, for attending.
Thank you, everyone.
Thank you, everyone.